Our world is graced with many a quality mathematician, a person to find the truths of the universe, build stuff, measure stuff, and solve the equations of the world. One such mathematician was Gottfried Wilhelm Leibniz. Born in 1646 in the Holy Roman Empire, Leibniz grew up to be quite the well-rounded fellow. No. Well-rounded fellow. Yes, Leibniz studied many things in his childhood. He grew up without a father who died when he was 6. His mother raised him, and much of her teachings influenced his later life. His father did have a lasting effect, however. Being a professor at a university, he had access to the library, which meant Leibniz got access as well. In his early years, he studied tons of books on an array of subjects. He later enrolled in that university and proceeded to get a master's in philosophy, then a master's in law. He even became a diplomat, helping restore some of the fragmented German peoples to their former glory. And finally, he was a mathematician. A dedicated mathematician who spent tedious amounts of time in books, learning and discovering, finding better ways and new things that would become his mathematical legacy. Deeply rooted in thought, and always sure that he knew what he was doing, Leibniz dedicated himself to some of the most important discoveries in math. He was a prolific inventor when it came to calculators. Leibniz was the first person to describe a pinwheel calculator in 1685, and he invented the Leibniz wheel. Used in the first arithmometer, it was the first mass-produced calculator. It was able to do addition, subtraction, division, and multiplication.
But look, 2 plus 2 equals 4.
Now, let's take a look at some of Leibniz's other accomplishments in mathematics and learning. First, his contribution to physics, where he invented the product rule. Leibniz argued this: let u of x and v of x be two differentiable functions of x. Differential of uv is this. Because of the fact that du times dv is negligible, Leibniz said that this becomes the differential form of the product rule. Then, to divide through by the differential dx, one would find this. Leibniz was one of the first to arrange problems into a matrix and manipulating it to find a solution. Infinitesimal calculus is the most significant of Leibniz's work. He was the first to employ calculus to find the area under a graph. It was also under a shroud of conspiracy that almost ruined Leibniz's career. Newton and him disagreed on who invented calculus. However, recently it is accepted that they both developed it independently, although Leibniz's notations have survived and are in use. The scuffle never reached full confrontation, fist to fist, but it did take place in a number of letters. One of the groundbreaking laws Leibniz invented was the law of continuity. Whatever succeeds for the finite also succeeds for the infinite. Leibniz made the principle to increase on concepts such as arithmetic operations. This would lay the groundwork for his infinitesimal calculus. As I said before, his notations were used over Newton's. Some of these notations included the Latin S for summa, which was the integral sign. Also the D for differentials. Y equals f of x was also one he coined and used, which continued later to represent the area under a graph and so on.
Hey Leibniz, what you doing?
I was just inventing these new notations. You see, I was looking at some Newtonian notations, and they're just so complicated. I mean, who can understand such things? And so, I decided to make notations that are good for everybody. Because everybody wants to learn.
Infinitesimal calculus?
Infinitesimal calculus.
Oh!
Leibniz is remembered as one of the world's smartest men. He made breakthroughs in physics, technology, and math, and also anticipated parts of philosophy, probability theory, biology, medicine, geology, psychology, linguistics, and computer science that would later become prominent. He wrote pieces on law, politics, philosophy, ethics, theology, history, and philology. He wrote these in many different languages, and some of his works have been lost to time. One thing is certain.
Alright.
Leibniz had a great effect on the world.